Record.
We
Yeah.
I have 6 hour, right?
Huh?
We get back to around 6 hour tomorrow.
2 o'clock. Yeah, so you'll go to 6th hour and 7th hour. Yeah, I uploaded earlier on YouTube already. I'm kind of on top of it. And I'll have you know, I'm back up to 21 subscribers. I'm ready to start making millions here. I'm going to become an influencer. Uh-huh.
You're 5 cents.
Can we come up with a phone?
No.
No,
That's neat. That's just neat to look at. That's today's date, 2/22/22. That's pretty cool. Anyhow, yeah, and it is a Tuesday, which is pretty cool. But we have to embark now on a little journey. We can't get through Algebra 1 without talking about this. And so we need to now talk about the properties of exponents. It's an interesting thing. We never really know, like, to what extent do we need to do this? Like, how deep do we need to go? Quite frankly, I think we cover this a little bit heavier than maybe we need to, but it's kind of one of those things like, well, since we're here, let's dive in and go full bore at it. And so before we can do some practice problems, because really the only way to learn how to do the properties of exponents is just to practice. You got to practice and just like practice. When do I distribute the exponent? When do I subtract them? When do I move them? When do I, you know, we got to get this kind of first coat of paint out there first. So by my count, there are 7 properties of exponents that you're going to need to be aware of. And we won't really address them formally as anything. You just need to know what they are and how to use them. Now, when I first give them to you here, I'm not going to have numbers. I'm going to use what we call generalizations. And so when you see like your first property says this, it says a to the nth power times a to the nth power. Don't be intimidated by that. A can be anything and m and n can be anything. This is just merely, again, in algebra and mathematics, how we put properties or rules or laws up to make them what we call generalized. So if I gave you a and I raised it to some power, and then I gave you the same a, that's key. Notice as you copy this down that we're using the same base, lowercase a and lowercase a. That enables us to use a property which says, hey, you're going to just combine those into a single a. Does anyone know what his exponent will be?
MN.
It is not mn, and that's exactly what any intelligent person would think it is. No, it's m plus n. And I can explain to you why that is, and I will, because I would want to know. I would cry foul, like, what? That's a load of baloney. It's actually not. Let's take a look at how sensible this can be. So, yeah, I mean, just look at like this problem this is an application of the first property. So if I gave you x to the third and I multiplied it by x to the second, if I visually put this out there for you, you could not then deny how the property works the way it does. X to the third, you agree, is x times x times x, right? And x to the second is x times x. And unless you struggle with counting, then you would agree that there are clearly, I knew that someone would do it. I figured it would come from this side of the room. Thank you, boys. Thank you to not let me down like that. Clearly, there are 5 of them, and you can see that that's a result not of doing 3 times 2, but rather of doing 3 plus 2. That's where the resulting 5 comes from, okay? So when you see a power and then another separate power, you add their exponents together. Do not multiply them. All right. On a related note, the second property that you'll see, and again, this will make more sense when we really start to put it into practice, is we have a to the mth and a to the nth. And this time, we're not multiplying them, we're dividing them. And this time, of course, I agree with the logic, I would subtract the exponents. And so the resulting expression would be a, but to the power of m minus n. And I would tell you again that the logic behind it is ironclad if you're willing to listen. It's just, think of it like this. If I gave you x to the 8th and said, let's divide it by x to the second. If you've got a good brain in your head, and your brain tells you, oh, I should put x to the fourth because 8 divided by 2 is 4. But where the property comes from, again, you can't refute the logic of this. If I write out x to the 8th, it looks like this. You would agree? And if I write out x to the second power, it looks like this. And you know this from like many, many years in school, that things from the top and things from the bottom of fractions can do what we call reduce, right? Right. So like I could take this x, cancel it with this x, and then I could take this x and cancel it with this x, leaving behind what I think is irrefutably, undeniably, x to the 8 minus 2, which is why the answer is x to the 6th, not x to the 4th. Good? Is that all? Are we done? Yeah, we're just doing properties of exponents. It's going to get a lot worse. Well, I mean, she asked. I was just going, and then she decided to ask. So let's keep going. Our third property says this. This time we do multiply them. Good. And this is interesting. Like, I still feel like I want to take m and raise it to the power of n, because that's clearly what it says. But that's not how these behave. When you have, we call this a rule of a power raised to a power. The answer to this one is a to the power of m times n. So this time we do actually multiply the exponents together. And again, if you're interested, which I don't know who would be, if you are, but if I gave you like 3 to the 4th power, and I said, let's cube it. I don't know if you know this, but eventually you're going to memorize, especially when you get to algebra 2. 4 to the 3rd is 64. But that number doesn't come into play here, because let's think about what this really looks like. What does 3 to the 4th actually look like? What does that mean? Right, and so it's 3 times 3 times 3 times 3. And what does it mean to raise it to the 3rd power? It means you do that effectively 3 times. So I'm going to go times another pack of 3 times 3 times 3 times 3 times a 3rd pack of 3 times 3 times 3. And again, you cannot deny the simplicity of what you see. 4 times 3 is in fact 12. And that's why you can count it for yourself. There's 12 of them right there, right? So that's your third property so far. We've done the three of the 4 most basic. The 4th basic one is this one. And it's a times b raised to the power of m. Notice the parentheses. Anyone have an idea as to how to attack this one? Good effort, really close. It is a to the power of m, but it is times b to the power of m. Really, you've seen this before. I don't know that, I don't know why we're not supposed to call it this, but really it's like a distributive property for exponents. I call it that. That's what we're effectively doing, is we're taking this power of m and saying, okay, since you're like clouding over this set of parentheses, you are going to become now the exponent of him as well as the exponent of him. Hence the a to the mth times b to the nth. It just distributes. So, for example, let's say we had 3x squared. If you're going to eat chips, you don't have to look around every time and smile because you're noisy, okay? Just eat your chips and enjoy them. It is obnoxious for the record, but it's your birthday, so I'm trying to cut you some slack, all right? But just try to be quiet about it, and don't worry about the reaction or anything like that, all right? Enjoy your chips. They look delicious. They sound delicious. I do not. I just want to continue with my lesson and have you focus on this and not the results of the audience. Thanks. Much appreciated. So if I take 3x and I raise it to the power of 2, I basically think about it as, okay, so the 2, the exponent on the outside, it says, I'm going to become your new exponent, and I'm going to become your new exponent. What is 3 raised to the power of 2? So the answer is 9x squared. The 3 got squared to make the 9. The x got squared to make the x squared. Simple pimple. Now come the 3 rules that I think cause probably the most trouble, not necessarily because they're difficult, just they're the ones that tend to somehow get like gummied up in our brains. And so the first one says this: anything to the power of 0. Have you ever seen anything raised to the power of 0 before?
Yeah, it just gives you like one.
Yes. Yes. Anything raised to the power of 0 will always be 1. If you ask normal people, I got to be careful. If you just ask a normal Joe, some random person, you would feel like the answer ought to be 0. It just feels so right, but it's not. And again, there is an explanation for this. I usually, if someone says, why is that? I would give them the following explanation. So imagine we had like 2 to the 5th power, 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd power, 2 to the 1st power, 2 to the 0th power. And again, if you are in the moment with me here, what you see will answer the question of how could this be? So you see the pattern, obviously, in my exponents going 5, 4, 3, 2, 1, 0, right? So anyone know 2 to the 5th off the top of your head? Good try. 2 to the 5th. You need one more times 2. It's 32. 2 to the 5th is 32, and mark my words, there'll come a point where you just know that, just like that. Now, 2 to the 4th is 16. What's 2 to the 3rd? What's 2 to the 2nd? 2 to the 1st, 2. And so if you just took someone off the street and said, let me show you a pattern here, and all you show them is the pattern of these numbers in the red box. Unless someone really is pretty out of it, they would be able to identify that, oh, I see what you're doing. You're dividing by 2, divide 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 by 2, 1. So that's about the best explanation I can give you as to how does that possibly work? Well, it just follows logically. Yeah, man. Yeah, that's not something that we'll talk about right now. There will come a point where we'll have like half powers that become roots, but that's a lesson for probably next week if I had to guess. Yeah, don't complain about it, okay? Nope, I don't want to hear your complaints. So that's the next property says that anything to the power of 0 equals 1. And then we do have 2 more properties, and quite frankly, they're pretty well interrelated. They are effectively the same property, but I'll give it to you from 2 different perspectives. The property in one of its states says this. And this one's huge. This becomes massively important for us. Say what? Oh, no, this is like rule number 6. Did I not clarify? Here, let me go back. Let me go back up and number them for you. If you like numbers, I like numbers. This was property number 1. This is property number 2. Sorry, maybe I should have been more clear. I apologize. This one is property number 3. There, again, you don't have to call them these. I don't care. I just need you to know there's 7 of them. This one is the 4th. The 0 power is the 5th property. Good. Sorry, Shirai, I didn't mean to lose you like that. Sorry, I don't know what I did there. But anyways, this one's huge. So this one is a little bit weird. And it says if something has a negative exponent, you take it and you move it to the bottom of a fraction like this. So you see that I had something raised to a negative power, but instead I acknowledged it as something to the same power but positive, and I kicked it to the basement, banished it to the cellar, and then put a 1. The 1 goes on top as what we call a placeholder. Without that, the fraction would be empty. So if the A is going to move downstairs, I need someone upstairs to kind of watch the front door. That's how that works. So an example of this would be quite simply, say you had 5 to the power of -2. The most common wrong answer that makes me really, really upset is -25. At no point during what I just said did I mention the answer becoming negative. What happens to the 5 when he has a negative power? He just goes downstairs. That's it. He doesn't change. He doesn't become a -5. He's not a different 5. Basically, the 5 says this: fine, you don't love me anymore. I'll go downstairs. And when I get there, I'll show you my new exponent is +2. Take that. He's still 5. And then upstairs, I go stick a 1. Now, what is 5 squared? So the answer is 1/25. And it works for algebraic stuff too. So like, let's say I had, I'm going to stay on this example for a minute. Let's say I had like 4x to the -3rd. I realize we're getting to the point where science has shown that it's hard for kids to keep listening. I need you to keep listening. We're not done. So stay focused. Don't go away. There are 2 pieces to this problem. One of them, his name is 4. Does 4 have an exponent? Sure he does. It's right there. It's a 1. Remember, when you can't see them, they have 1s. So should I move the 4? No, he doesn't have a negative exponent. But what about the x? What's his exponent? So the way this answer winds up looking is 4 says, I'll stay up here. I'm fine. But then x, whoop, gets booted to the basement and becomes x to the 3rd. It's a very simple property. It's simple once it clicks. If something has a negative exponent, you move it downstairs. And of course, I would want to know, hey, Mr. Ahern, what happens if it's already downstairs? And that's the final property. Property number 7 says this. If you have something like this, where something already finds itself residing in the basement and it has a negative exponent, you want to take a guess as to what we do? Nope. If it had a negative exponent upstairs, we banish it downstairs. If it's already downstairs, we move it back upstairs. And so the answer to this one would be, I'll just take and move it back upstairs. Yes, like this. Yes, in fact, we spend a lot of time in mathematics doing exactly that. Things that have negative exponents, we simply move them up if they're down or down if they're up. That's that. I'm not sure I understood your question.
Because then 120 is smaller than 25.
You'll see naturally. If you still have that question when we're done with our examples, then let me know and I'll try to answer it. But negative exponents will just naturally pop up when they want to, and then we have a method for dealing with them. And that's properties 6 and 7. Well, again, let me see if going through these examples answers your questions for you. Negative exponents are going to show up when they want to. It's not my choice, but when they show up, then I have to have a means to deal with them. I really think that we should see if you still have that question in 10 minutes. Does that sound fair? Because I don't exactly know how to answer it other than just showing you. Let's see what happens. That's all the properties. Now we have to practice. And I have 6 examples, 5, 6. I could do 50 examples and never would I cover every possible situation. The people that are going to be good at this are the people that want to get them right. The people that want to say, I want to conquer this like a puzzle. So I'm going to begin really, really lightly with you here. So my first example for our notes would be this: 4x to the 4th times 2y to the 2nd times x to the -10th. These are going to get a lot uglier in the next 10 minutes. So I would look at this right now, and I could make a case for property 1, and I could also make a case for property 6. And property 6 is the one where we see a negative exponent and we move it downstairs. So what I'm going to do is I'm going to lose you now, and you're going to say something like, how did you do that? So here it goes. The first thing I'm going to do, and I don't know how I lose kids on a 3rd grade math question, but it's not your fault. I'm going to take 4 and I'm going to multiply it by 2. I'm going to take 4 and I'm going to multiply it by 2, and I'm going to get 8. Like terms only apply when we're doing addition and subtraction. Multiplication and division is a free-for-all. You can multiply anything by anything. Like terms, that terminology only applies when we're trying to do plus or minus. Multiplication is a mishmash. You just take things you find and you multiply it all together. So I hope you understand where I got 8. I didn't add exponents or anything like that. I simply did like a 3rd grade math problem. A lot of times people thought, oh, I thought I should do 4 plus 2 and get 6. It's like, no, those are not exponents. That's just 4 times 2. Got it? Now, at this point, I'm going to go through and I'm going to employ property number 1, which said, look here, I'll color code this for you. I have an X here and I have an X here. And property 1 pretty clearly states that when you have something to the something and the same something to the something else, what do you do with your exponents in this case? You add them. And so as part of my answer, I'm now going to incorporate an X. And what is the power now that results from doing 4 plus -10? Beautiful. And as you'll see, we hate that. It's not wrong. It's just not done. But we're going to tackle that in a minute. And then let's go through and let's look at the Y's. It's okay. It's just X to the something times X to the something, and it's just X to the something else. Did you want me to put a 2 in front of the X? Is that what you're saying? That he just won't talk to me. Is that what you're saying? Well, then by the same logic, if we go back to the very beginning of the notes, were you okay with X to the 3rd and X to the 2nd just making X to the 5th? You're okay with that? Then you just answered your own question. Why didn't I put a 2 in front of this one? For the exact same reason that I'm not going to put a 2 in front of this one. If you got X to the something and X to the something, you're just going to get X to the something else. You're not going to put a 2 in front of it. You're thinking of addition, Cooper. X plus X makes 2X. And then lastly, I'm going to look at the Y's, and I'll color code this for you also. There is a Y right here, and there is no other Y for him to go with, and so I'll just stick that one at the end of my answer. Now, another thing you're going to come to just accept is the fact that negative exponents are no bueno. Hence our desire to give you a property to fix them, if you will. And we fix negative exponents by just moving them. If they're up, we move them down. If they're down, we move them up. So I look at this and I say, there are 3 guys in this answer. Their names are 8, X, and Y. Does 8 have an exponent? Yes, it does. You better start answering that correctly. 8 has an exponent of 1. Is that negative?
No.
Then we don't move the 8. Does X have an exponent? It's negative?
Yeah.
Then we move it. So in our final answer, we're going to leave 8 upstairs. We're going to leave Y upstairs. And we're going to move X downstairs. And what will we rename X once he gets down there? Very good. This is how we tackle simplifying properties of exponents problems. We apply the rules that we can until eventually we look at it and say, there's nothing else I can do. Next example. A good mathematician will see this as 3 separate entities. Sometimes we'll put time signs in between them. Sometimes we won't. Don't think that it makes a difference, okay? There are 3 entities in this problem. Their names are 5, X, and Y. We will combine any that we can find that need combining, and after that, we will move any that require moving, and then we'll call it a day. So let's take a look at the 5. Does he have an exponent? Good answer. He does, and it's a positive 1, and so we'll leave it right there. Let's take a look at the X. He has an exponent of 0. What I think it was property number 5. What are we going to be? What's going to become of X to the power of 0? It's going to become a 1, which I will say renders it effectively pointless. So I could just say, you might as well not even be there. Right. And 5 times 1 is like, what's the point? And then finally, Y, what are we going to do with that dork? Now we're getting it. Good. So my final simplified answer looks like this. 5, you hang upstairs. Y, You go downstairs and change your name to y to the third. When we move something, we fix its exponent by moving it. That's the trade-off. All right, I got one more before they start getting a little bit tougher. This one will be the quantity of 3x y to the negative fourth z squared all to the power of negative 2. You should see 4 entities. You got to start training yourself to know what those words mean. There are 4 entities. Their names are 3, x, y, and z. And identify that each of them is like its own guy. So you want to take a stab at what step 1's going to be? Perfect answer. Property 4. Distribute that exponent. Take it and shoot it through. So the negative 2 says, I am going to become your exponent, your exponent, your exponent, and your exponent. It's going to shower and rain itself into the parentheses. So before we skip any steps here, I'm going to show everything in as raw of a manner as I possibly can. It's going to be 3 now to the power of negative 2 times x to the power of negative 2. Now, big brain question coming up. I don't know who's feeling tough and buff. Anyone want to take a shot at what y's new power is going to be? You say 8? I love that answer. You caught me off guard. It was brilliant. It was beautiful. It was perfect. Think about, we just used property 3 while using property 5 or 4. Neat, huh? So this x or the y, think about it in case you just got lost. He already had a power of negative 4. We assigned him an upper power now of negative 2. Negative 4 times negative 2. Jackpot, good job over there. EV is positive 8. And then that leads us over to the z. What is z's new power going to be? Good job, you guys. Z to the negative 4. And at this point, it's not a matter of combining any parts that can go together. There's no one to mash with anyone else. The 3, the x, the y, the z, they're all what we call singletons. They have nobody to go with. Now I just go into the mindset of stay if you're fine, move if you're bad. Tell me about the 3. Does he stay or go? He goes. So on the bottom of my answer, I will have a 9. Because when he gets there, he changes his name to 3 to the second, which of course we all know is 9. X, will he stay or will he go? He goes. And he becomes, hey, everyone, look at my new name. I'm x squared now. What about y? Does he stay or go? He stays up top. And what about z? And that is that. Once you start understanding how the rules all play together, not bad. And very intimidating at first. Okay, I got a couple more examples, and then I think we'll just start trying some problems out here. So probably 3 more examples. This is where they get a little rougher just because it's hard. This would be easy if there was one of me and one of you. But we have so many different brains that work different ways. It's hard to find a method that everyone agrees with. So I'll walk through this the way I would do it. And then if you don't like this method, then I'll try to come up with maybe an alternative strategy. First thing I do is I look at it as a 4th grader would, and I think to myself, do I see just a 4th grade fraction? Forget x's, forget y's. Do you see a 4th grade fraction? I do too. And I'm going to put a red box around it, and I hope you agree that that fraction is just 5/10. Forget you're in algebra class. Heck with that. What does 5/10 reduce to? 1/2. So at this point, I can at least say this much. When I build my answer, I am certain that my answer will contain those 2 pieces. Now, for the next part, this is where it gets a little rough. The x's won't be bad. The y's, we're going to have to talk. What do you think about those x's? Anything catch your eye? Right. And so this is where we start to see a little bit of branching off. Like Corbin's approach is very literal, very by the book, and very perfect. I heard him say subtract them. And that's exactly perfect application of property number 2. That is exactly what you should think. And then once you get better, maybe you start thinking like Cooper said, wait a second, there's someone trying to trick me here. So in its basic form right now, following the rule, what is 2 minus 0? And since it's positive 2, I shall put x to the power of 2 on top. And again, let's go back and address something that Cooper said. If you spot it, you see that the x to the 0th power on bottom, let me put a little blue bubble around it. Do you guys all agree that this really just equals 1? And as I think we've decided, anything that just equals 1 is pretty well pointless, isn't it? So I see that and I think you don't even really have to be there. But even if you are, I can still apply property 2 and figure out what to do. Now, this is where the you-know-what hits the fan. And if you're not listening, we're dead. There are 2 approaches to this problem. One of them suits people with very good basic skills. The other, if you don't subtract and change signs well, then you better go for option 2. Option 1 first is a literal application of property 2. And if you don't like this, I might have your back with plan B. So I'm going to take the -4 on top and the -10 on bottom, and I'm going to subtract them. And because I care about you, I'm going to show my work. It is +6. And the wrong answer here is someone might just lazily look at that. Oh, it's -14. Duh, -4 minus 10. Watch out. It's -4 minus -10. You've heard me employ that pause before back when we were doing slope. The pause is there to kind of force us into thinking, okay, the minus sign is coming in because of property 2, but then I got to wait and go, ooh, what do you see? Minus and a negative. And what does that become? -4 plus 10, +6, y goes on top. Now, that answer looks a little ghetto-y, right? It's like, what is that thing? It's all off kilter. So there's a couple things I would do about this. Number 1, I would say, hey, 1, thank you for your service, but your service is no longer needed. You were there to hold, but now I've got the x and the y, you can go. And then I would probably recenter it because it looks like a wacko did it. So I'm going to rewrite this answer as x to the 2nd, y to the 6th over a more centered 2. You have to do that? Nah. Just feels nice. Now, if you did not like that thing I just did with the subtraction, here's an alternative plan for you. I'm going with green boxes now. What do you guys tell me about that y? It's got a negative exponent. What do you think we could do? We could move it downstairs and make it y to the 4th. And then let's also look at this thing in the blue box. Tell me about that y. So you can move it upstairs and then you subtract, and what's 10 minus 4? Just like that. So if you get intimidated by that whole minus and negative thing, then you can always move negative exponent-y things first to make the subtraction a little bit less intimidating for you. Good. Last example. You feeling okay so far? Yes, I don't know why we didn't do that 20 minutes ago. He's going big. I could do this all day. You don't want me to. So I'm just going to whip up one more. We're going to do 4x times x to the -3rd y squared all to the power of 4 all over 10 x to the -6th y squared times 3 times x times y. We've kind of reached the point now where we got to put it all together. The only property I think that's not going to show up here is the 0 property. I don't see any things to the 0 power, but this is a mess. I will give you the one best piece of advice that I know how to give, and you'll take it or you'll leave it. But if you take it, I think you'll find I'm really glad I took that advice. When you see problems like this, you should tackle the top as if it were its own problem first, and you should tackle the bottom as if it were its own problem first. You should simplify the top as much as you can, and then simplify the bottom as much as you can before you let the tops and the bottoms start interacting with each other. Having said that, let's focus on the top. Just the top. What do you think we ought to do first? What do we have to do first? Absolutely. You know your order of operations, and the order of operations dictates in a case like this that exponents go before multiplication. So this 4 says, hey, everybody, watch out. I'm coming in. Woo, woo, just like that. And he feeds himself now as a new exponent for the guys inside. Note, of course, here that the 4 and the x that were originally in front of the parentheses, they're unscathed. What about the new x's power on top? What is it? Nice job. What about the new y on top? Nice job. Now, like I said, I'm going to be true to what I said. I'm going to be consistent with what I said. I'm going to simplify the top as much as I possibly can. And what else? There's one more thing I can do on top. What is it? Yeah, and you can actually say that. It's not technically combining like terms, but that expression works for me because it tells me that you're thinking the right way. I got to mash the x's together, don't I? So does the x, the first x you encounter, does he have an exponent? Yeah, remember 20 minutes ago, you kept saying no. Now you're going to say yes, 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 with the side order of yes. It has a power of 1. And now when I use property number 1 and I take my x to the 1, and my x to the negative 12, and I mash them, what do I get? Nice job. So my top in its simplified form is 4, x to the negative 11, y to the positive 8. And I can say, top, stay there. I'll be back. I'm going to go work with the bottom now. The bottom will not require 2 steps because there are no parentheses to clear. So the top is going to happen quickly. What's the first thing you see or that a 4th grader would see? Has nothing to do with algebra. I see a 3 and a 10. Has nothing to do with algebra. I just look right here and I go, hey, there's a standalone, just a regular old 10. There's a regular old 3. And what's 10 times 3? Nice. And then I'm going to go through now and I'm going to mash up my x's. And again, we're going to keep hitting this point again and again and again and again and again. Does this x have an exponent that where I'm moving my pen? Does the y? Yes. So alphabetically, we should always do x's, y's, z's in order. If we hit the x's first, what is the result of their exponents added together? Nice job. X to the negative 5. And then what about the y's? Good job. Now at this point, we have no choice but to basically do what we did in the last example, and that is first do the 4th grade part. Attack the fraction, the thing that has nothing to do with algebra. And I'll put a red box around it. The fraction that has nothing to do with high school math is in that red box. And what does that reduce to? It reduces to 2 over 15. When we reduce fractions as a common accepted practice, we leave whole numbers and not partials inside of fractions. The whole number over whole number, the best we're going to get is 2 over 15. Now let's take a look at the x's. And again, I hope that you're solid with your basic skills. If I asked you to do subtraction on this, what is negative 11 minus negative 5? It's negative 6. And watch out. The fact that it said negative 6 means that I'm going to put it on the bottom as a positive 6. If when you subtract and use property number 2, you get a negative answer, don't put in a negative answer on purpose. Put it in as a positive, but put it in the bottom. And then finally, let's do the y's. I'll switch colors here to green. What is 8 minus 3? And since it's 5, where's it going? And that is a brutal long introduction to what's going to be an interesting day and a part. So I'm going to end the recording here. Would you like me to hand out the worksheet today or just wait and let Miss Willoughby give it to you tomorrow? Okay, I will